about aging, more than often, the first thoughts that come to mind are the physical changes to our appearance that we associate with getting older, things like the wrinkles, sagging skin, loss of hair, because these visible, more aesthetic parts of aging usually start to appear long before the more troublesome sort of age-related health conditions that we also associate with getting older. But what we know is that actually everything to do with aging starts not on the surface level, but deep within our bodies at the cellular level. And the changes that we're experiencing on the outside are a reflection of the underlying molecular aging processes that are going on inside of our bodies. So if we really want to fix aging, then what we need to do is to target aging at the cellular level. So why have we not been doing this? Well, the reason is that for a long time, it simply hasn't been an option because we didn't know how, not even as scientists. And for a long time, scientists actually believed that you couldn't really do anything about the aging process at all. We actually believed that it was irreversible. And this is where the field of longevity research comes in, because it's been a field that has been dedicated to try and work out what are the root causes of aging inside at the cellular level, and is there anything that we can actually do about it? And recent scientific advances in this longevity field have meant that we now have a much deeper understanding of the aging process, and we now know that aging is actually a modifiable process. So just as there are things that we can do to speed up aging, there are also things that we can do to slow and, most importantly, even reverse the aging process. And this has led to some pretty big headlines recently, and perhaps the most relevant to you guys is the top one here, which was all over the press when it came out, which was when scientists demonstrated that they had actually reversed the age of a woman's skin cells by 30 years. So this is an incredibly exciting time to be involved in anything to do with aging, because the research that is coming through now is going to truly rewrite aging as we know it. And this means that we're really entering a new era. It's an era of cellular regenerative medicine. Now, we know that we can tackle aging at the cellular level, meaning that no longer will we just be targeting the lines and wrinkles on the surface, but actually targeting aging from its root cause. So what has actually changed scientifically to make us now believe that we can truly reverse aging at the cellular level? Well, a key thing to really hammer home, and I've said this a couple of times now, is that we understand that absolutely everything to do with aging starts from within our bodies at the cellular level. So you can name me anything to do with aging and there will be a cellular root cause, and this is really important, because it means that whilst we're very focused on treating aging up here at the surface level, where we really need to be looking is down here at the cellular level. And in the skin, this is our fibroblast cells. And this has led to scientists such as myself investigating a concept called biological aging, which is basically the decline in cellular processes that ultimately results in the aging process. Now, what many of you may not realize is that as scientists, we now consider people to have two ages. We consider them to have their chronological age, which is simply just the number of years since they were born, but we also consider them to have a biological age, which is the rate at which you are aging on the inside. So it's like the age of your cells or your body on the inside. And what's really interesting is that quite often a person's chronological age and their biological age don't quite match up. So for example, you could have someone here who's got a chronological age of 40, but when we measure their biological age, it's more like age 50. So this means that they are aging faster. They are aging faster at the cellular level than they should be according to their birth certificate. And on the flip side, you can have someone that's aging much slower, so they would have a higher chronological age and a lower biological age. And it's this difference between your chronological age and your biological age that's a good measure of how well you are really aging. Now, for a lot of people, when I talk about biological age, they're kind of like, I don't really know if I want to know what my biological age is. But for us as scientists, this concept of biological age, and more importantly, this discrepancy that we seem to see between a person's biological and chronological age, proved two really important points in the field of aging. The first thing that it showed us was that aging was not fixed, because this is something that had been argued for a long time in the longevity space, that maybe aging was something that we couldn't do anything about because it was a fixed process. It was like a programmed setting in our cells that once we were born, it kind of started and there was nothing you could do to stop it. But if this was the case, then your biological age should always be exactly the same as your chronological age. And what this discrepancy shows is that there's something going on at the cellular level to either speed up or slow down the aging process. And if there's something going on at the cellular level and we can work out what it is, then maybe there's an opportunity to intervene to improve and slow the aging process. The second thing that it demonstrated is that it's actually possible to measure the aging process in quite a simple way. So often these biological age tests are just simple finger prick blood tests. And up until then, it was kind of argued that, yes, it's fair enough scientists talking about slowing biological age and slowing the aging process, but how on earth are you ever going to measure it? Like, how can you set up a clinical trial? Are you just going to wait for someone to die? This really isn't practical. So this offered a way that we could actually measure if something that we were doing as an intervention is actually going to have an impact on the cellular root causes of aging. So the key question now is, what is actually causing us to age at the cellular level? And what we know is that there are essentially 12 key things that go wrong at the cellular level in all cells across our body, so not just our skin, this is every cell in our body, that ultimately drive the aging process. And these are very famously referred to in the longevity space as the hallmarks of aging. And you can see there are many different hallmarks here, everything from mitochondrial dysfunction, so like our energy production in our cells, through to chronic inflammation, damage to our DNA, changes to the genes that are switched on and off through epigenetics, many different things here, some that you may be more familiar or may have heard, some that you may not have heard. And I don't have time to go into all the hallmarks of aging in this webinar. But what you really need to remember is that these hallmarks of aging, so these root causes, these things that are driving everything to do with the cellular aging process, don't happen up here on the surface, which is where we currently treat aging. They happen down here at the cellular level. So this is again just reinforcing that we really need to actually start addressing the aging process down here at the cellular level. And the human body is actually made up of around 37 trillion cells. So this is huge. It's a big number. And this means that these hallmarks are happening in every single one of these 37 trillion cells. So you can soon see that it very quickly becomes a major problem if your cells are not functioning properly. So this is why regenerative medicine, regenerative aesthetics is now really focusing on ways to target the cellular level and actually regenerate the cells, because if they are functioning correctly, then everything else will follow. So the hallmarks of aging drive all aspects of skin aging. And to put this into perspective, I just want to look at some common skin changes that you see in your patients every day and explain how the changes at the cellular level, so these hallmarks of aging, are actually driving the characteristic age-related changes that you are seeing on the surface in your patients. So first of all, let's just look at pigmentation. We know that pigmentation is definitely something that gets worse as we get older. And what we know is that pigmentation on the skin is actually driven at the cellular level by DNA damage, which is a hallmark of aging. So as we get older, our cells' ability to repair DNA damage declines. So this DNA damage starts to accumulate in our cells. And in the skin, excess UV exposure causes further DNA damage, which cannot be repaired effectively. And it causes the melanocytes, which are the pigment-producing cells in our skin, to start acting a bit weird, and they start overproducing melanin. So this is why we start to see this classic pigmentation get worse as our patients get older. Another hallmark of aging is chronic inflammation. Now, inflammation in the body and in the skin is good acutely when we're dealing with like an infection or a wound or something like that. But what is not good is continuous inflammation in the body, this chronic smoldering inflammation. And what we know is that as we get older, we tend to suffer from a buildup of inflammation that's just not really fully turned off. And again, in the skin, this actually damages the skin structure. So it not only degrades collagen and elastin, but it also damages the blood vessels. So we start to see this classic redness and rosacea that seems to get worse, especially in older people. Senescent cells are also another hallmark of aging. So these are cells that have become damaged beyond repair, and rather than the body actually remove them, what the body does is it basically just puts them to sleep. However, these cells don't just sit there and sleep quietly. What we now know is that they actually secrete inflammation, and this damages a lot of the other cells around it. And as we age, the number of senescent cells actually increases, and it's estimated that up to 30% of the fibroblasts in the skin become senescent. So not only are they sitting in the skin taking up space, but they're also not secreting collagen and elastin anymore, and they are also secreting inflammation, which is degrading the healthy collagen and elastin that we have left. So not good news when it comes to our skin. And finally, another hallmark of aging that's incredibly important in skin aging is mitochondrial dysfunction. So the mitochondria are the energy powerhouses in our cells. They give the cells the energy to stimulate skin cell turnover and promote healing. So when they become older, or when we become older, they start to dysfunction. They don't work as effectively. There's not enough energy production, and this reduces skin cell turnover and also increases healing times. So hopefully you can see how some of these hallmarks that are happening in our cells are actually leading to the visible outcomes that we are seeing on the surface. One area that has gained a tremendous amount of research surrounds a molecule called NAD. So what is NAD? Well, it's a natural molecule. It's found in every single cell in your body. And I like to call NAD the most important molecule for life that you've probably never heard of. And this is because if you didn't have any NAD in your cells, you will literally be dead in 30 seconds. And that is because it's important for two major things in the body. The first thing is cellular energy production, where it helps to turn the food that you eat into the energy that all of your cells need to function. And the second thing is for cellular maintenance and repair, because it basically acts like a fuel to drive many of the cellular repair processes in your cells. So as a general rule of thumb, if you've got high NAD, you will have lots of energy and lots of repair. But if you have low NAD, then you will have less energy in your cells and also less repair. So why is NAD linked to aging? Well, the real problem that we have is, like many things with age, NAD levels also decline. So when you're young, you have really high levels, but as you get older, they get lower and lower and lower. And in fact, cellular NAD levels are found to decline by around 50% every 20 years, which is quite a lot when you think how important it is in the body. And when NAD becomes persistently low, the energy production is turned down, repair is turned down, and this results in the accumulation of damage and increased biological age and many of the symptoms and negative health consequences that we associate with the aging process. So scientists have said, okay, we've got this molecule. It's obviously very important, and it's important in keeping our cells healthy, and its decline is correlated with poor cellular health. So what happens if we don't let it decline and we keep levels of this NAD molecule high as we age, or indeed restore NAD back to youthful levels in older people? What would happen? And this is what they did. And to cut a very long story short, there are now hundreds, if not thousands, of studies in cells, animals, and now humans to show that NAD seems to be one of the only things that can improve all 12 hallmarks of aging. So as NAD goes down, all of the hallmarks of aging seem to get worse, but as NAD is increased, all of the hallmarks of aging seems to get better, which is pretty amazing that this one thing seems to have such an impact on all these different hallmarks of aging. And the benefits across the body are vast. So everything from improved cognitive function to improvements in metabolic conditions, repair of DNA, muscle function. And in some key studies, scientists working with NAD discovered that by replacing NAD in aged cells and tissues, they could reverse age-related damage back to a youthful state. In other words, the scientists could no longer tell the difference between the old and the young tissues. So many scientists now believe that maintaining high levels of NAD in your cells as you age is a really promising way to combat the aging process by maintaining cellular health. And when it comes to skin, NAD also seems to have tremendous benefit. So we know that NAD declines in skin as we age. There are studies showing this, and we know that if you restore it, it leads to multiple benefits. So NAD, for example, it helps to preserve the health of the fibroblasts. So remember, they are the cells that are producing our collagen and elastin, so critical for healthy young skin. And higher NAD is being shown to protect the skin from DNA damage. So not only repair DNA damage, but actually protect it. And we also know, we know that this is incredibly important because UV DNA-induced damage from the sun is the leading cause of skin aging. We also know that NAD in the skin cells activates cellular recycling pathways that get rid of those troublesome senescent cells that I described earlier, and also reduce inflammation. So that's another two key hallmarks of skin aging that I was describing earlier that NAD helps with. Now, one obvious question that I get is that if NAD is so important, then why does it actually decline in the first place? And there's actually been found to be two main reasons for this NAD decline. So the first one is that older cells simply have more demand. So they've got more damage, they've got more inflammation, so they've got a higher demand for NAD that acts as a fuel to power these repair processes. And the second issue is that our ability to actually make and recycle NAD declines as we get older. So our cells actually have a really powerful pathway called the salvage pathway, which actually makes and recycles all the NAD that we need. But unfortunately, a key enzyme, which can be seen here, called NAMPT, in this pathway declines as we get older. So as our skin cells get older, as we get older, we have less of this enzyme that is making our NAD. So you can see that when you put both of these two things together, this increase in demand and this reduction in production and recycling, you will naturally get a deficit in NAD. And the next question I then get is, okay, so how can we actually boost NAD in our patients? NAD is a very unstable molecule, and this means that it doesn't survive in the gut. So oral NAD is not an option, despite there being many products out there that boast that they contain pure NAD. It doesn't matter how pure the NAD is, it will not survive the gut. So that's really important to remember. So for this reason, NAD IV infusions have become a very popular method because the idea here is that if you infuse the NAD directly into the blood, you bypass the gut to avoid this problem. But actually there's an even bigger problem here, and that is because NAD itself is a very large molecule. That means even if you bypass the gut using IV infusions and put it right into the blood, NAD still struggles to get into the cells where it is actually needed. So the IV will get it into the blood, but NAD does very little in the blood. It must get into the cells because this is where the mitochondria are, this is where the DNA repair enzymes are, this is where all of the pathways that NAD interacts with are found. Now, current scientific evidence shows that only a couple of cell types actually have channels big enough to let NAD across the cell membrane. So cells generally don't let big charged molecules like NAD just pass in and out. They have to have special channels, which are like little doors. And we know that there are very few cell types that actually have these channels that specifically let NAD in. So effectively, it gets stuck in the blood. And furthermore, despite the huge number of clinics offering NAD IVs, there is a severe lack of clinical data on both the safety and efficacy of NAD IVs. So there's actually only one clinical study that looked at what happens to the NAD once it's infused into the blood. Where does it actually go? Does it actually get in the cells? And this clinical study showed that actually the NAD is rapidly metabolized, so it's broken down into precursors. The other study that is just about to come out shows that not only does NAD not increase cellular levels of NAD, so it puts it in the blood, but it doesn't increase NAD in the cells where it is needed. But more worryingly, it showed that it induces an inflammatory response in the blood, which shows why many people suffer from unpleasant side effects when they have these IV infusions. And this is because you are putting a large amount of a molecule that is normally just found inside the cells. It's never normally found in high concentrations of blood. You're putting it into the blood and the body is going, oh my goodness, what has happened? We should not have this amount of NAD in the blood. It is not naturally found there. There must have been some sort of trauma where cells have burst open, so it initiates an inflammatory reaction. So please just be very mindful that a lot of clinics are offering it. There's a lot of opportunity to offer it, but at the moment, the scientific evidence suggests that this is really not a good way to boost NAD levels. NAD injections, again, these have also become really popular. Unfortunately for these, there is actually no clinical trials for safety or efficacy on this method. And given that you're injecting pure NAD into the extracellular space, it's likely that they'll have the same problem as NAD IVs, as the NAD can't get in the cells, albeit you're using it at a lower dose. So the side effect profile should theoretically be reduced. But again, this is all theory because there are actually no clinical trials to show this. Now, because of these issues with these types of methods, one method that became really popular way to boost NAD is to use oral supplements containing not pure NAD, but NAD precursors such as NMN or NR. They're the most famous ones. Now, these precursors are basically the raw materials that the cells use to make NAD, with the idea being that if we can't give the body the whole NAD molecule, then if we give the body more of the smaller raw materials to make NAD, then hopefully it will actually turn them into the bigger NAD molecule. Now, there are many human clinical studies on NR and to a lesser extent on NMN to show that they do boost NAD. But unfortunately, what we're now learning is that this is also not the best way, because using this method does not address the root cause of the problem. It does not address the reasons why NAD is declining. So remember, the reasons why it's declining is because, first of all, the pathway that takes these precursors and turns them into NAD, that declines with age. And secondly, we've got an increased demand. So you're not actually fixing the problems. And now what we're seeing in some of the human clinical studies is that by ignoring this problem, we are actually causing further issues like methylation problems as these precursors start to build up in the cells, because our cells can't deal with them because they don't have the enzyme that is capable of turning them into NAD. So what is the best way to boost NAD then? Well, basically, you've got to fix the root cause of the problem. Things like the precursors are not fixing this problem. Remember I said that NAD declines because the key enzyme, this one here, NAMPT, in this NAD production pathway declines with age. So if you take a precursor like NMN, it doesn't fix this issue. It's kind of like sending more raw material to a factory when we know for a fact that all the machines are broken. And if you really want to fix the factory, you've got to turn back on the machines, you've got to turn back on the enzyme. Because actually, when we are young, our cells are very good at making NAD via this pathway, but this declines with age. So to date, the latest science shows that the best way to boost NAD is actually to fix the root cause of NAD decline by using ingredients that specifically switch back on this enzyme to turn back on the cell's natural NAD production pathway and lower the inflammation and also the demand. And this is exactly how Nuchido TIME Plus works. It was formulated to fix each of the causes of NAD decline and restore youthful NAD production. And Nuchido TIME Plus is the only product that has been proven in a full double-blind human clinical trial to address these root causes of NAD decline. So I'm just going to briefly take you through each of the ingredients in the formulation and explain what they actually do. So the first group of ingredients work to restore natural NAD production in the cells. So we have alpha lipoic acid and also Sophora japonica, which contains quercetin and rutin. And all of these ingredients are working together to activate this key NAMPT enzyme, the one that declines with age, the one that produces all our NAD when we are young. These ingredients are switching it back on. And again, we have proven in our human clinical trial that we increase levels of this enzyme in the participants. Nuchido TIME Plus also contains green tea extract and also parsley extract. And these contain EGCG and epigenin respectively. And what these do is they work together to inhibit inflammatory proteins and enzymes that actually are degrading and wasting NAD. So these are the things that are increasing that NAD demand. So this ensures that not only are we stopping NAD from being wasted, but we're also pushing it towards more beneficial pathways like energy production and cellular repair. And finally, Nuchido also contains the NAD precursor, nicotinamide. And nicotinamide is a raw material that the body uses to make NAD. So in a way, it's similar to NMN or NR. It's one of the smaller building blocks for NAD. But we do not use NMN or NR because what many people don't realize is that nicotinamide itself is the natural precursor that your body naturally uses to make NAD. And it has a much better bioavailability and absorption than these other more famous precursors. And this helps to further boost the increase in NAD levels in our cells. Now, the supplement industry is filled with companies that are making wild claims about their products without any evidence. But at Nuchido, we like to do things differently. And given my scientific background, it was essential that any products that we make are supported by evidence from human clinical trials. So we have done a full double-blind, placebo-controlled crossover clinical trial in humans on the Nuchido TIME Plus supplement. And I've also published several papers on the role of NAD in aesthetics and regenerative medicine. And all of this data, all of these trials, all of this research is open access. And if you'd like copies of these papers, please get in touch and we'd be more than happy to send them to you. So in our clinical trial, we demonstrated that not only does Nuchido TIME Plus boost NAD, but it also lowers inflammation, lowers glycation, and reverses biological age. And these benefits at the cellular level were found to be translated into benefits across the whole body by observing things like improved skin health, increased energy levels, and also improved sleep quality. And because we are focusing on aesthetics here, let's just take a little deeper dive into some of this skin health data. So here in this study, we demonstrated that increases in cellular NAD levels on the inside lead to visible improvements in skin health on the outside. So in this trial, which had 30 participants, they took the oral Nuchido TIME Plus supplement for 3 months. They had no aesthetic procedures, no changes to skincare. But what you can see is that as we saw an increase in cellular NAD on the inside, so at the cellular level, we also saw improvements to skin health on the surface level, most notably to levels of redness and rosacea. And anyone working within the skin health space will know that even with aesthetics treatments, redness and rosacea are incredibly hard to treat. And this demonstrates that we were able to see a reduction, a significant reduction, by just using the Nuchido TIME Plus oral supplement. So where does NAD fit into the world of aesthetics in general? Well, there are a number of ways that it can play a significant role. So firstly, I think we need to just point out that we have an aging patient population. So those people who are coming to you for treatments now in their 40s and 50s are hopefully still going to be coming to you for treatments in their 60s and 70s. And whilst this is really great for business, it also presents a potential problem. And that is because many of the procedures that you are doing rely on the healing and regenerative capacity of the skin. And we know very well that this declines as we get older. So it's absolutely critical that we start using things like NAD to maintain cellular health, to maintain the repair capacities in older cells, to ensure that we can get optimal healing and results in our patients as they age. And the other thing is that you might not have realized is that many of the treatments that you are currently performing actually work by activating cellular pathways that depend on adequate NAD levels in the cells. So, for example, if you are performing lasers, microneedling, both of these things essentially work by inflicting localized damage to the skin, and that then activates cellular stress pathways that promote cell turnover and collagen production. But guess what? Many of these pathways rely on NAD. So you certainly don't want to be stressing cells that are already stressed because they have low NAD and they can't actually switch on and power these repair pathways. So it's really important to understand that maintaining high NAD levels is really critical to ensure that cells are in optimal condition to respond to treatments for best results. A third thing to mention is the role of NAD for helping with symptoms of menopause, because many patients do start to present in aesthetic practices, especially, well, obviously women, when they are going through menopause. And what we know is that whilst NAD declines in both men and women, in women, right at the time when NAD levels become really depleted, our hormone levels also decline. So obviously NAD is very important for things like energy production and repair, but guess what? Estrogen especially is also very important for energy production and repair and for lowering damage and things like inflammation. So right at a time in a woman's life when she's going through menopause, it kind of produces the perfect storm when NAD is dropped, estrogen is dropped, so we've got this real lack of cellular energy and damage building up in the cells. So we actually see that during menopause, a woman's biological age massively increases. It's estimated by up to 9 years in just 6 months during the transition between menopause or perimenopause and menopause. So it's really important to look at things like increasing NAD because they can actually help to counteract some of the negative effects of the decrease in hormones. So for example, the most notable reported benefit when you do increase NAD is a significant increase in physical energy and not feeling tired and fatigued all the time. Also, many women report that when they boost NAD levels with Nuchido TIME Plus, they see a significant reduction in brain fog. And a lot of people report that it's like they've had a sudden cloud that's just been lifted off them and they didn't realize how foggy the brain was until it had been removed. Sleep is another one. We know that NAD is very important for regulating circadian rhythm, which becomes disrupted during the menopause. And if you are improving cellular health, you are counteracting some of the negative effects like the lower estrogen has. And if you're improving health at the cellular level, you then start to see the benefits on the surface level. So people report an improvement to things like their hair, skin, and their nails. So people aren't just improving at the cellular level, but also getting the benefits of not just how they feel, but also visibly how they appear as well. So hopefully now it's very obvious about how NAD fits into the aesthetic space. And I'm just going to finish off with some frequently asked questions that we quite often get. So first of all, can you take Nuchido TIME Plus with other supplements? The answer is absolutely yes. You can take other supplements alongside. The only thing that we do suggest is just double check that your patients aren't doubling up on any of the ingredients. So, especially people that are taking a lot of different supplements, check that they don't have any of the same ingredients that are in Nuchido TIME Plus to avoid exceeding daily limits. Another question that I commonly get asked is, what age should we start taking Nuchido TIME Plus or trying to boost NAD levels? Is it too early or is it too late to start boosting NAD? And what I always say is that most people that come into your clinic will have an NAD deficiency. And this is because NAD levels have already declined by 50% by the time we are age 20. So first of all, if you have younger patients, it's never too early to start actually maintaining NAD levels, because the more you can maintain NAD levels, the more you keep repair switched on to kind of have a preventative approach. And also it's never too late to start boosting NAD levels in older patients, because if you can increase NAD levels, we do see that repair that has been turned down is actually turned back up again. The other question is, how long does it take to actually see or feel results? Now, this is a one that varies depending on the person. So what our studies show is that even if somebody doesn't feel an immediate benefit, so they're not feeling immediate change or an increase in energy, we know that in all the participants in our studies, within 7 days, NAD is already starting to increase inside the cells. And most people start to feel benefits within the first month. And these are things like an increased energy, reduced brain fog, and better sleep. They are the things that people tend to see and feel, once those increased NAD levels start to translate into the cellular benefits, we do start to see these things within the first month. The longer term benefits, so I'd say these are the things that the visible signs, so the changes to the hair, the skin, the nails, these tend to start to appear after 3 months, which is why we do recommend trying to get patients to start with a 3 months trial of the product. The other main question I get is, how is NAD different from collagen? Because collagen is probably the most famous supplement used within the aesthetic and skin space. So hopefully you already know the answer to this, but just in case, let's just have a quick look at the differences here. So first of all, let's just look at youthful skin cells. So in youthful skin cells, we have these young, healthy fibroblasts. They have lots of NAD, lots of cellular energy, high levels of repair, and low levels of inflammation. So the hallmarks of aging aren't really causing a problem at this point. And this means that they've got lots of collagen and elastin being produced, and we get this lovely youthful skin. Now, in older cells, the hallmarks of aging are really kicking in. And this means we've got low NAD, we've got decreased cellular energy, low levels of repair, lots of inflammation, and generally our cells are not as happy as they used to be. So we've got less collagen, less elastin production, and we get these characteristic signs of skin aging. So collagen acts here. It's trying to fill the gaps. It's not addressing any of the cellular problems. It's simply firefighting. It's trying to just fill the gaps that are appearing with collagen. On the other hand, NAD is working right at the top of this problem. It's working at the root cause of the problem. It's actually trying to improve the health of your skin cells to get rid of all these problems, to make them act more like youthful skin cells again, so they will actually start producing their own natural collagen and elastin. So really, you can use Nuchido TIME Plus and collagen together, but you can see how NAD is really going a step above collagen and actually fixing the root cause of the issue.